Hello and welcome to a new episode of BEEMAN livestream BLS004, and in today's episode we will add authentication to a NestJS GraphQL API. But first of all, let me start off with an exciting news, and that is that I received my first sponsor on GitHub. Thank you very much, Tran, for being my first sponsor. I'm super excited about this, and yeah, thanks a lot for sponsoring me, and you get 2 hours of my time being the first sponsor. So I reached the sponsorship goal that I've got one sponsor, and this sponsorship goal beholds that you get 1 hour or 2 hours of my time. So yeah, let me know if I can do something for you. Anything that's related to code will be valid. So without further ado, let's go and look at today's episode. So today, adding authentication to NestJS and GraphQL. So in the previous episodes, we built a NestJS server in an Nx Workspace, and we added an API with the NestJS plugin, and we added a few libraries. So we added a core library, a data library for data access, and a course library. So the first thing we're going to do right now today is add an authentication library. And this will be done using the NestJS plugin. 1 second. Start the terminal here. And I'm on a new branch, so let's go ahead and do nx generate narwhal nest lib and create the authentication library. Now, for those of you that were here yesterday, you've seen that we've created a data model with Prisma, and one of the first things we'll do is actually model this user model that we have inside of our authentication library. So the library got created, and inside here I'm gonna add a new file called, in the folder models, called user.ts. Yes, create a file for me, and this is export class user, and we're gonna decorate it with the object type decorator from NestJS GraphQL. Now what we can see here is that we have these fields, so let me go ahead and quickly create those. So as before, we're going to make them all nullable, and we're having an ID, which is a number, and then email, first name, last name, and password. But password is not a property that I'm going to expose, so I'm not going to add the field decorator to it. And these, of course, are all strings. 1 second, please. I'm sorry, folks, I had a small interruption here. Let me know if there's anything off with the stream. It'd be kind of sad if we wouldn't record it. Let me quickly verify if I can see if everything seems right. Okay, at least I'm live. Please let me know if anything seems off. I'll happily hear it in the chat. So these options, email, first name, last name, and password, are all type string. So let's properly type them and mark them as optional in TypeScript. And that's it for the user model. So next thing up that we want to do is create the mutations for the login and register operations. So in order to do this, we're going to create a resolver that's called auth.resolver.ts. And here we're going to export a class AuthResolver, and decorate it with the resolver decorator. And inside of here, we're gonna have a register and a login method defined, and both of these are mutations. And what these mutations actually will do is they will take some arguments, and in case of the login, we're going to call it input. This is going to be AuthLogin input. And the same goes for the register. Register mutation, we're going to say AuthRegister input. We're going to create a DTO here for both of these. DTO. We're going to create the auth-login.input.ts, which exports a class AuthLogin input, and we're going to decorate it with the input type decorator. And on login, make sure that this gets import. On login, we want to have a field called email of type string and password of type string. And these fields are all, of course, required. So that's one. Let's quickly create the AuthRegister input as well. So make this again export class AuthRegister input. Let me copy over the email and password field from the login, and then two of these are going to be optional. So first name, last name are both optional, and we don't really care if people submit them. They may not. They're optional in the database, so let's make some optional during registration as well. Now back to our AuthResolver, we can now simply import these two inputs, and very similar to what we did before was we're going to return this.server and then the name of the method we want to call into and pass in input. Now let's here inject the private read-only service, the AuthService, which is the next thing that we're going to define. It's the service where we actually handle these things. So I'm going to say auth.service.ts, export class AuthService, make it injectable. Now this AuthService needs access to the database, so we're going to say inject private read-only data is the data service, which will import from Beehive/data. And this is what we now can use to do stuff with, well, when we want to register or log in a user. So let's make sure that these services work. Let's import the service here. So it's there, and then we can have TypeScript help us create these methods. Import it here. And these are the two we need to implement. Right, but first of all, let's make sure that we provide both the resolver and the service in our auth module. And because we need access to the data service, we also need to add to the imports the data module from Beehive/data. Now we don't even have the server running, so let's do something here. Let's go over to package.json and just start. That's not the way to go, I think. Well, let's not bother with it for now. Let's just say ngserve API right here, and this should start the API. And if all went well, we should see that we have no errors here. That's perfect. Now, if we go to our app module, in the app module, we need to import authentication module. So authentication module will be imported here. And then when the server restarts, we'll get an error. Okay. So the error is mutation login was defined in resolvers but not in schema. So it seems to be that our AuthResolver here has a mutation which is provided. Yes, I think I know what this error is. If you use the mutation decorator with the code first approach, and this is what we're using, remember to explicitly provide a return type, e.g. mutation, and then here a method that returns a type. Now what we want to return for both the login and the register mutations is a token and the user. So inside our models, we're going to add a file called user-token.ts, export class UserToken, decorate it with the object type decorator, and then what we're going to return here is a field called token of type string and a field user which is of type user, which is the sibling object here that gets imported. And this is the shape we want to return from both the login and the register methods. So let's see. Once we go back to the AuthResolver, we can now tell both of the mutations to use and return the user token. And if all went well, the server should now restart without errors, which it doesn't. Fun times. Cannot determine GraphQL input type for the input. Okay, another issue here. So cannot determine GraphQL type for the type input. These inputs here are a string, and the way it currently works is that it will try to sense which type is here. So AuthRegister input and AuthLogin input, but we actually have to define these explicitly. So in order to do this, we're going to change this to an object and pass in a property name, and then add a property type which returns a method with AuthLogin input. And this should happen the same here with the register mutation. Add a method type, add a property type which is a method that returns AuthRegister input. And now with those two out of the way, server still failing. Let me double check. This is some live coding, people. This doesn't get more spontaneous than this. Let's double check. Make sure your class is decorated with the appropriate decorator. Okay, AuthRegister input type. We didn't add the add input type decorator. So the errors of the NestJS GraphQL integration are super clear generally. There's a few quirks, as you can see, things you have to keep in mind, like returning the right type in the resolver argument here. But other than that, once you're used to it, it's all pretty straightforward. So with that, we can take a quick peek at our playground here. Let's load up the playground and check the documentation here in the schema. And we can see we now have the login and register mutations available. So this was all as expected. And I think it makes most sense to start out with the register method, so we can register new users. So let me take a quick peek in my reference project to make sure I'm on track here. Let's open this one first. So what we actually want to do is make sure that we don't have a user with that email already. So this is a database level check. We marked in schema.prisma, we said that our email needs to be unique. But what I'd like to do here is add a separate way and just basically, if the email is already taken, that we throw a, I think, unauthorized or bad request, maybe a bad request exception. Cannot register with email input.email. So this is the thing we want to return if we can't register with this email, right? And I need to say throw new bad request exception and pass in the error message. So let's go. Let me quickly peek in my reference project to see if everything is going the way I like. Which in general, this is all going the way I like. I'm super glad my computer is no longer freezing up as I was in the first episodes. Yes, so what are we gonna do here is we're gonna basically call into this.data and say find user by email. So before doing this, we're gonna say if we found the user with this email, where email is equal to input.email, we're not gonna allow it. We need to make the method async. And this is the first thing we can check. So as you recall, in our env file, we set our default admin. So this one is created. So if we go back to our playground here and we run the mutation login, register. And in the input say register with this email. And for password, let's just say password. And of this query, take the token and the user. What we'll see here is that user, first of all, it tells me that user needs to return several fields. So let's get the email and the ID. And it now gives me an error, you cannot register with email@example.com. So first step is there. And for now, the next step will be create the user and return it. So we're gonna say const created is await this.data.user.create. And in the data object here, we're gonna say email. Well, I think we can again just destructure the input method. Yes, that all works as expected. And the last thing to do here is return the created user and the user key. So this register needs to have the shape of a promise with type user token. And that gives us the user here and the token here. Now this token we currently don't know yet. We haven't implemented the tokens yet. We're going to use JwtModule JwtTokens to generate this. So for now, what I'm going to do is create a simple sign method that takes the user ID, this.sign, user ID. Let's call it this.sign token, takes user ID as a string, so user created.id. And once we implement JWT, we will actually implement this method. But I'm first going to create it here. And add some debugging string. There we go. I'm sorry, ID is a number. Okay, so let's make sure, okay, this all works as expected, yes. So, with that in place, we should now, if we create a user with this email, it should still fail. But if we say admin2@example.com, there you go. We now get back admin2. So this is user registration. As you see, we get a temp ID, but this ID will, in a bit, have a signed version of the job token. So there you go. That's the first part. Let's look at the second part, login. And the login method, what that needs to do is find the user by email. If it doesn't find this user, we need to error out. So this is the opposite of the register. So we're going to say const found equals await this.data.find user by email. And going to add input.email. Now we're going to make the method async. And here we're going to say if not found, throw new not found exception. User with email input.email does not exist. When it does exist, what we actually want to know is the password valid. So what we want to do here is have some sort of method that we can say this validate, if only I could write, the input password, so the password that we get sent in, we need to validate if this is the same as the user.password. So now we can the found user password. And this will most likely be an asynchronous operation. So let's create this validate one, and this will return a promise of type Boolean. And for now, let's just return false. So this is just going to return false anyway. And let's check if this denies, because we want to add a new error here. So if not password valid, throw new error. Invalid password. Let's not make it more complicated than it needs to be. Invalid password. So now when we run the login operation, we'll first check if we have an email address that doesn't exist. That should trigger this error. And the second one, if it does exist, it should trigger the invalid password error. And after that, if we're happy with both the user being found and the email being valid, if we still didn't throw an error, we're gonna get return the user, which is found, and token, which is this.signed token found.id. Similarly to what we returned from the register method right there. So to strictly type this is a promise of user token. That's what it returns. So let's see how that works in the playground. So let's copy over this method here and call it login. And login takes the same shape. So let's first start with an email that we know that doesn't exist. There you go, user with email, blah, blah, does not exist. Now, if we take an email that does exist, we get invalid password. And this is because we don't validate the passwords yet. Now, what we could do here in this validation method is a simple compare if password is the same as the second password, but we don't want to store the passwords in clear texts. We want to store them signed. We want to sign our passwords before they go into the database. So in order to do this, what we're going to do is add a simple password helper. So I'm actually going to do it in the authentication helper. I'm going to create a file here called auth.helper.ts. And I'm going to export a class, and this class is going to have two static methods on it. One is called validate, which returns a promise of Boolean. And the other is hash, which takes a password of type string and returns a promise of string. Now the validate takes the plain password, so the one that gets put in by the user, and the hashed password, which is the password that we store in the DB, and it needs to do the comparison. And in order to do this comparison, and the hashing, we're gonna add Bcryptjs. So we're gonna say yarn add Bcryptjs. And once that's installed in the packages inside node modules, we're gonna import compare and hash from Bcryptjs. And in here we will simply compare the password, I'm sorry folks, the password with the hash password. And in order to hash it, we'll just return the hash of the password with a number. And this is, I think the number is the difficulty, but I'm not fairly sure. Should look it up. So this auth helper, we can now use it at any place where we want to do a validate or a hash. So let's go back to this auth service. And in this register method, where we create our user, what we actually want to do for password is call the auth helper and hash it. And we're going to hash the input password. Now we need to make sure to await this. So what I'm actually going to do is say const password here is await the hashed password and pass that in directly. So that's one. The passwords will now be hashed on save. And then in the validate method, we can simply say, well, let's not even bother with this validate method. What we can do here is call straight into the auth helper and validate these two. So there you go. This makes this method obsolete. So with that in place, we now have the login method implemented, and let's make sure that this still fails. So admin2 with password should now fail because we have a hashed version of that password. But if we register admin3 here, we get a token and a new user back. And then if we log this user in, we get back the same user information. So this means that we have now implemented the register method and the login method. The passwords get hashed on save and they get validated with the password that we pass in with the login. So let's take a look at what's next. The next step will probably be adding JWT or JWT if you spell it out, and add a JWT strategy and make sure that we can actually generate tokens. These tokens should store the user ID, which we can later use to verify that the request is coming from the users. Let's go. Let's first install, here we go. Let's first install NestJS JWT at nestjs/passport and passport-jwt. Sorry, I need to say yarn add. And once this is in place, I can add the strategy. Let's make a first quick commit that says implement auth library with login and register, because this is like one body of work. Second body of work is going to be adding authentication using JWT. Now JWT works with the term strategies with certain, our passport actually works with certain strategies, and we're going to create a strategies folder, and inside we're going to say jwt.strategy.ts, and this exports a class JWT. Let me quickly get my example here. Yes. And in order to make this work properly, what we're going to do is we're going to extend the passport strategy that comes from NestJS Passport, and we're going to pass it in the base strategy. Now this one should be imported from passport-jwt. Passport-jwt. But it looks like this is not strictly typed, so we have to do it manually. Now that's the first step here. Second step is define the constructor and inject the auth service here. Let's call this one simply service. Now, and in the supercall, what we're actually going to do is we're going to pass information into the password strategy that we're extending. So what we're going to add here is like jwt from request. And what we're going to do here is execute a method, extract JWT, which is also not being auto-imported. But here we go. And the method here is from header, from auth header as bearer token. That's quite a large one. And we have to set a secret or key here, and I'm just gonna do Beehive secret 987 blah, some secret. Now with this in place, the only thing left to do for us is implement an async validate function, And this is the method that actually gets run when we validate the request, and we get a payload passed in which has the shape of a user ID and a string, which is exactly the shape that we're sending out, that we're signing here. So if we look at the auth service in the sign method, we call it, we get a user ID. Let me quickly make sure I'm doing the right thing here. Otherwise I have to go back. Yes, okay. So what we actually have to do here is sign a value, and our value will be user ID. So let's make it like this. We have a payload, user ID, and that takes the ID. So we're talking about the shape of this payload. Now in order to make this fully typed, let's go ahead and create jwt.dto.ts, export class jwt.dto, user ID of type number. So we at least have a reference that works with both. So this is the payload, and once in the next step we'll sign this actual payload, but we at least now know that it has the right shape. And in this strategy we can also now use the jwt.dto. And in this validate method we're already sure that the token is valid, so we can assume that the user ID that's being passed in is valid. So what we can do is say const user equals await this.service.validate user, and pass in the user ID that we get from the payload. Now if we don't get a user back, we're gonna throw a new unauthorized exception. Otherwise, we're just gonna return the user that we got back. So let's quickly implement this validate user method here. And what this does is straight away call into the database, and let us create a helper method, find user by ID, which takes an ID of type, which takes a user ID which of type number. So let's generate this method. I'm gonna put it next to the find user by email up here, async, and we're gonna return this.user.find1, where ID is equal to user ID. So this is a simple helper method that we can use here. And so our validation basically beholds like, hey, we need to check if we have a user with this ID. If we do, then we're going to consider the request valid. Now this would probably be the place where you can also add stuff like check if user is expired, all that kind of jazz. For now though, this should totally be it. And let me check where we're at with the service. Yeah, so we need to mark this service injectable because otherwise it cannot inject the auth service. And because it's an injectable, we need to provide it here inside the providers array. So let's do that right here. And let's see if this, there you go, there's errors. Let's restart the server and see if the errors are still there. And when that's all good and well, there we go, it's not all good and well. There's an error message. So let's see, you cannot find module passport, okay? So, yarn add passports. and check if that resolves the error. So there we go, serve the API again, Nx serve API, and once that runs, we're going to take a look at actually signing the request. I'm curious if this loads like it is. There you go. So one thing we need to do to get this all working now is inside our authentication module, import the required NestJS modules. So what we're doing here is import JwT module, and we need to pass it the register method. Now register takes an object, and this object is the secret that we just talked about. So the secret that we have defined here. Let's do it like this for now. We should probably want to use the config service at some point, but let's stay with this. So now we register our module, and this means in our auth service we can now import the JwT service. So let's do that. JwT service from NestJS. And this is the service that we're going to use to sign the actual key. So now we can go here and say this.jwt.sign payload. And this all together should now give us valid tokens when we log in a register. So as said, we before had the temp token. If we now run the same, we get a JWT token. And this JWT token, if you paid attention, you realize that this should have an user ID of type number as its shape. So let's go online and say validate JWT and see if this is actually the case. So validate JWT tokens. I can pass it in here and you'll see user ID 3. So this is a nice place where you can add some more metadata to your payload. So if we would like, we could add stuff like denote if the user is an admin, or pass them their roles, something like this. So nice. With that, we added JWT to our API. And now that we have this token back, it makes sense to start protecting a few endpoints that we don't want to expose for everybody. So for instance, we don't want all the users that are not logged in to update, delete, or create new courses. We only want them to list a course, an individual one, or a list of courses. So basically all the mutations that are create course, update course, delete course, or create lesson, update lesson, or delete lesson, we at least want to make sure that the user is logged in. So let's add that as a first step. And before I do that, let's go quickly over the changes here. Yeah, so this is one single commit, implement JWT strategy. There we go. Now the way to protect endpoints in GraphQL with Nest is by using AuthGuards. So let's go ahead and create our AuthGuards. And for that, I'm going to create a folder guards here. And in that, GqL-auth.guard.ts. And this is going to export a class GqlAuthGuard. And I'll get my example, my reference. This class is going to be an injectable. And this class extends AuthGuard that's coming from NestJS password. And the type of AuthGuard is JwT, JWT. So this is the name of the name of the strategy. And because this strategy has JwT strategy, it uses this part this snippet here, and it uses that in lowercase. So that's the name of the strategy, and we should define a getRequest method, which takes a parameter context of type execution context from NestJS common. And what we're going to do here is figure out the context. So we're going to say .ctxs GqL execution context dot create with the context we get passed in. And in our return, we're going to say return .ctx.getContext.request. So this is basically the way how we can extract our context information in a GraphQL. So we basically want to get a hold of our request, which is coming in from, for instance, the playground, where we make an HTTP request. We do a post call to our API, and this is what we want to use to fetch our request. So because it's an injectable, we need to provide it. So we open a module here and we provide the GqlAuthGuard. Now let's verify that the server still starts, which it does. And let's go here to the create course. So test course in the DB. We can see we can now just freely add 1, 3, 4, 5, 6, 7, and we want to protect this. So in order to do this, we open the course resolver, and we're going to annotate this mutation with the useGuards mutation. And we're going to say we want to have the GqlAuthGuard providing this for us. Now, if we look at the import here, we see that this got imported with the deep import, the relative import. So let's quickly jump into this file, index.ts, and export lib.guards.GqlAuthGuard and change the import here. So with that in place, verify that the server starts, and once it does, we should now get an unauthorized method. So we can no longer freely execute this method because we're not authorized. Now, if you take a look at the Jwt strategy that we have, let's close this all out and open the Jwt strategy. You can see that we get the Jwt from the request, and it uses the extract Jwt method, and it wants it from the auth header as bearer token. And what this actually means is that on each request, we're going to send along HTTP headers that have an authorization, an object with a key authorization, and a property bearer and our token. And when we send along this token, we should be able to get the request. So let's double check this doesn't work. We get a false token. But if we take our token from login here, the one that we just got back, we should be able to create a course, as this user is now verified in the database. So there you go. I can now make calls, and this is great. We protected our create method by using a guard. So let's quickly add the same guard to the other mutations. Then open the lesson resolver. The lesson resolver, and do the same thing. Now in this case, we're actually interested in protecting all the endpoints. So what we can do is simply use the same useGuard with GqlAuthGuard for the whole class. And this should protect all these endpoints. So let's quickly invalidate this one. So let's add invalid behind it, invalid. Now we can see we can no longer delete lessons. It will all give a unauthorized. Hey, let's make sure that this works as expected. That's interesting. I'm pretty sure I'm giving the, there you go. Okay, so it turns out that you can space append stuff to a token and it will still work. I learned something new today and you're all part of it. But if we have an invalid token, let's change the 8 for a 7, then it should no longer work and be unauthorized. Okay, good. So we got authorization. Well, we got authentication in. Now we can add authorization. So we're going to create a commit here. So the commit is add AuthGuard to protect GraphQL queries. Actually mutations, but they're all of the subset queries, superset queries. Now one more thing to add here is actually the notion of which user is making the request. So what we want to do when we create a course, we actually want the owner to be registered. So the person that creates the course, it would be nice if we could register this with the course itself. So what we can do is pick the actual user off of the context. And for that we're going to create a new decorator. Let's close this one out. So in libs auth source lib, I'm going to create the decorators method, decorators. The decorators folder, I should say. And in that, I do CtxUser.decorator.ts. And what this file does, it exports a const. This time not a class. And to create this const, we assign it to the create parameter decorator method that comes from NestJS common. Now this takes a method which has data and CTX. CTX is the input. And in here, we're going to go to the GraphQL execution context, create the context with this CTX, get back the actual context, and from the request, get the user. Now, it doesn't really matter if you don't really understand what's going on. The NestJS documentation has quite a lot of information about what's happening and how about switching of the context. But the only thing that we really need to know is that if we now add this decorator to one of our endpoints, we can know who made the request. And this is what we can use to store data about this user. So to do this, in the let me first go to the index.ts here and make sure I export the CtxUser decorator. And then in the lesson resolver, let's start with this one. Add CtxUser. And we're going to locally reference to this one as user. Make sure that we also export the user model. So export user model, export this from the auth library. And now you see we're importing CtxUser, GqlAuthGuard, and user all from authentication. Now we're injecting it here, and that should give us access to the raw user object once we do this. So let's log this one out. Now if we open the console here and clear it up and then go to the create lesson endpoint, we should see, once we fix our token, once we fix our token, we should see that we now can create lessons, and once we do that, we get a reference of our database object. So we now, per request, have a reference to this user. And what I like to do on all authenticated methods, always inject this. So authenticated stuff, the first injected property here is always user, and I'm always just passing in user.id inside the actual methods. Now this is what works for me. You might have other things that work well, but I really like this. And then I say each method at least starts with user ID, which in this app is a number. So update lesson gets a user ID first, and delete lesson gets a user ID as well. And this is a great place where you can start verifying stuff. Can user ID actually delete? Let's add that to do. So this is a to-do. We need at some point to check if a user ID actually can delete stuff. So there's various ways to do that, but it's kind of out of the scope of what we're trying to achieve here. So this is all good. Let's move on to the course resolver. Yep. And do the same thing here. So we decided that the first two methods can be accessed public. We're not really interested in who is logged in. And in here, we're going to say CtxUser, which is a local reference to user of type user. Pass in user ID and create course. Now copy this one over. Update, delete, and update the methods. I'm sorry. Say user.id, and inside the delete course as well, user.id. Now update these methods and say I'm going to get user ID string. Update course is going to get user ID of string. And delete course. And with that, we now added the mechanism to verify if a user is actually who he is. We can check on that in the actual methods. So let's quickly commit this. Add CtxUser decorator to get logged in user. Now, if this all went too fast and you want to check it out, there's a repository on GitHub where you can check the source code of this project. So feel free to check it out there. I'll upload it in a sec. I even got people starring me. I really appreciate it. There you go. Ciao, Derlies, my biggest fans. I love you guys. Thank you so much for support. I really, really appreciate it. So let's see, we have 6 more minutes to go inside this hour. I'd like to keep these things at max an hour. So in 6 minutes, let's see if we can make a relationship between our user and our course. So what I'd like to say is that on the course, I have an author property of type user. And let's for now make it temporary, make it optional. And this author will in the database be represented with an ID field. So I'm going to go here and say relation, which is a method, a decorator. Decorators are generally methods. And the fields I'm referencing is authorId, which references the remote model ID. Now with these two in place, we're going to run Prisma format. I'm going to quickly change the song because this is too wild for me at this moment. This is more chill. So we added this authorId and author property, and if we now run the Prisma format command, we should see, well, we shouldn't. What's going on here? This validation doesn't work. The relational field author uses the scalar fields authorId. At least one of those fields is required. Okay, yes. So what it's nagging about is that where I make this relationship optional, I also need to make this ID field optional. So let's see if it formats now. It does. Very good. Thank you so much. And it adds the course property user. So we can later say, give me all the courses of this user. To make it a bit more, give it a better name, basically make it courses, plural. Now let's quickly do the same. Should we do the same? Now, for now, author is enough to have on a course. So that's that. Now, when we actually create a course, we want to use this authorId to attach it to the course we're creating. So next to the input that we destructure, we're going to say author. Now this needs to refresh. Oh, actually, we need to run Prisma apply. Prisma apply. So for those of you who didn't check yesterday, how Prisma works is you define a schema, and this will eventually create a file for you, a client. So if we check this client that gets generated right now, we shouldn't see any reference of author, which we don't. We can't find anything. Now, if we run this Prisma apply, which does the migrate and the generation of this client, we should have a reference to author in this file. So let's quickly check it out. There you go, AuthorID. And it now knows stuff about the author. So that means that in our code, where we actually use this one, we can now say, we should now be able to say, when you create a course, hello, author, there you go. And what we want to do here is connect the author to an existing one, where ID is user ID. And I'm making a small mistake here because user ID is not a string, user ID is number. You probably all seen this way before I did, but let's go with it. Okay, so with that in place, we're going to start the API again. And what we want to check, if we create a lesson right now. Now let's create a new course. If we create a new course, that's called course by author. It gets created, so that's good. And let's make sure that we can actually retrieve the author. So as you've seen right now, we can retrieve the course, but we only get lessons. So this is the last ones created. Let's fetch just the last course. And what we actually like to do is have an author here, which is the user object. So we can say author.email and then get the email of the author and the ID, so we can link to their profile. So in order to do this, we need to open the model course.ts. And in here, we're going to say we have author of type user. This is the object type we're getting from GraphQL, from the Auth library. I'm sorry there. Now this presents the entry on the object. So right now we can see that this is invalid. There's no field author on type course, but when we refresh it, this field does exist. However, the data does not get retrieved. So there's two issues. First of all, we should mark it nullable because we have entries in the database that don't have an author marked. So that's one. Once the API is restarted, we should now be able to run this query again. There you go, author is null. And the reason is that we don't include this relationship when we retrieve a single course. So let's go to our course service. And inside our course service, where we retrieve a single course, we're going to add an include here and say include author is true. And for good measures, we do the same thing here, author true. And what I like to do is create a property private read-only course includes. And this is gonna say lessons true and author true. Use this one in the includes. So this is course includes, and on this request we want to do the same thing. So both the list of courses defined many call and the individual calls defined one call now include their data, and this should give us an author email. There you go. And in the list as well, we can now say give title and lessons. Well, number 2 didn't have an author assigned, but number 12 did have an author assigned. And with that, I'm gonna wrap up this episode of BEEMAN Livestream BLS. You can check this stuff on YouTube. I'm trying to upload them as soon as possible and annotate some interesting parts. So please, if you're on YouTube, give me a subscribe there. You can find me by searching for BEEMAN.DEV, because if I have more than 100 subscribers, I can get a clean domain name. So that would be cool. Thank you all very much. I'm gonna leave it for today. Thanks so much for tuning in. This was BEEMAN Livestream BLS. Catch you all later. Bye bye.